Dear students, now today we are going to learn about the number system. As we know that we have 10 digits, which are those 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Using these 10 digits we can form any number of numbers. Here these are considered as the digits in the number system. Now in this number system we are using the many different sets of numbers. The first set of number is natural numbers. Natural numbers. Here the numbers which are used to count are called natural numbers. To count we start with 1, 2, 3, 4, like that we will count, so that the natural number starts with 1, 1, 2, 3, like that it goes. It has no end point. Observe here, for the natural numbers we have a symbol that is n. N is the symbol for the natural numbers. N represents natural numbers. Next set of numbers we are having the whole numbers. Whole numbers. Whole numbers. The symbol for the whole numbers is given by W. And this whole number is slightly different from this natural numbers, because in this natural numbers we don't have 0, but in the whole number we have to include the 0 here, so it should start from 0, 1, 2, 3, 4, it goes like this. It goes like this. This is the set of whole numbers. Next we have the third one, that is the integers. Integers. Integers are the third set of numbers. Here the integers are represented as Z, R, I. Z is also represented as integers. I is also used to represent the integers. Here the set of integers contains the whole numbers along with the negative numbers. So set of integers are having, or is a group having positive numbers, negative numbers along with the 0. I am going to write it here. Observe it. -3, -2, -1, 0, 1, +2, +3, like that it goes. It includes negative numbers, positive numbers along with 0. Here 0 is neither positive nor negative. Here we have the negative numbers. They are considered as negative integers. They are -1, -2, -3, like that. Similarly, the positive numbers are considered as positive integers. Z plus, they are +1, +2, +3, it goes like this. These are the three set of numbers. Next we have the another set of numbers, that is rational numbers. Next we have rational numbers. What are rational numbers? Rational numbers are the numbers which are in the form of P by Q. The numbers in the form of P by Q, where not be equal to 0. Q should not be 0 and P and Q should not have the same factor. That is the condition for the rational numbers. Usually rational numbers are in the form of P by Q, where Q, that is the number which is present in the denominator, should not be equal to 0. Next, we have irrational numbers. I will give you the examples for this rational numbers. Example, the symbol for this rational number is Q, and the numbers are like this: 1 by 2 minus 3 by 4, 7 by 2, whatever you can write. These are all the numbers which are in the form of P by Q. Observe here, P by Q. Q, that is the number in the denominator, should not be 0. Next we have irrational numbers. Irrational numbers. What are irrational numbers? The numbers which cannot be represented in the form of P by Q. The numbers which cannot be represented in the form of P by Q. For example, I am going to write pi. What is the value of pi? S. In everyday life, we are using this pi value as 22 by 7. But remember, 22 by 7 is the approximated value of the pi, but not the exact value of pi. The exact value of pi cannot be identified because it is having more number of digits after the decimal point. Observe here, 3.142, like this goes. It is having crores of digits after the decimal point. For any calculation, for every time, we cannot use the value of pi as a whole. That's why we are using only the approximated value of pi, that is 22 by 7. So actually, irrational number, pi is an irrational number. Irrational numbers are the numbers which cannot be expressed as in the form of P by Q. The numbers which can be expressed in the form of P by Q, they are rational. The numbers which cannot be expressed in the form of P by Q, they are called irrational numbers. Next, we will consider one more set of numbers, that is real numbers. Real numbers. What are these real numbers? Real numbers are the known bigger set of numbers till now. The known bigger set of numbers which includes both rational and irrational numbers. So it includes both rational and irrational number. Irrational numbers. Real numbers are the known bigger number set which includes both rational and irrational numbers. That means rational numbers and irrational numbers together will make real numbers. Next, we will concentrate on some other type of numbers. That is, as we know that they are even numbers. Even numbers. As you know, even numbers are the numbers which are exactly divisible by 2. They are 2, 4, 6, 8, 10. It goes like this. These are all called even numbers. Next we have the odd numbers. Odd numbers. Odd numbers are the numbers which cannot be divisible by 2. That is 1, 3, 5, 7, 9. Here comes the odd numbers. Next we have the prime numbers. What are these prime numbers? Prime numbers are the numbers which have only 2 factors. What is this? We are confused. Shall I write it here? Observe here. I am going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I am going to write all the factors of every number. For the first one, what are the factors? It is only 1 is the factor for this one. For 2, how many factors are there? 1 and 2. Have you understood? 3 can be divisible by 1 and 3 can be divisible by 2. It is not possible. It can go with only 3. Let us come to the 4. 4 is divisible by 1, 2 and 4. 5 is divisible by 1 and 5 only. 6 is divisible by 1, 2, 3, 6. Similarly, 7 is divisible by 1 and 7. None other number can divide this 7. Number 8. Number 8 is divisible by 1, is divisible by 2, is divisible by 4, is divisible by 8. Come to the 9. 9 is divisible by 1, 9 is divisible by 3, 9 is divisible by 9. What about 10? 10 is divisible by 1, 2, 3, no, 4, no, 5, yes, 5, 10. Observe here. Observe the factors. Which are the numbers having only 2 factors? I am going to mark them. 2 is having only 2 factors. 3 is having only 2 factors. 5 is having only 2 factors. Similarly, 7 is also having only 2 factors. What about 9? 9 is having 3 factors. Have you understood? Similarly, which is the next number that is having 2 factors? That is 11, 13, 17, 19, 23. These are all called prime numbers. What are prime numbers? The numbers which have only 2 factors. The numbers which have only 2 factors, they are called as prime numbers. Example: 2, 3, 5, 7, 11, 9 won't come. Next, 13, 17, 19, 23, 29. Have you understood? 27 will not come because 27 is divisible by 1, 3, 9, 27. Okay. 27 is not having only 2 factors, it is having 4 factors. So these are the numbers having only 2 numbers. You can continue like this. You can find any number of prime numbers here. So next we have the composite numbers. Composite numbers. What are these composite numbers? Observe the table. The numbers which have 2 factors are considered as prime numbers. The numbers which are having more than 2 factors. More than 2 means it may be 3, it may be 4, 5, whatever. So these I am circling them. Next one, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25. These are the numbers having more than 2 factors. Not equal to 2 factors, it is more than 2 factors. They are called as composite numbers. The numbers which have only 2 factors, they are called as prime numbers. The numbers which have more than 2 factors, they are considered as composite numbers. But we left only one thing. What is that? Yes, 1. What is this one? This one is neither composite nor prime. One is not a prime number and one is not a composite number. Do you know the difference between the prime numbers and the composite numbers? Prime numbers are the numbers having only 2 factors. Composite numbers are the numbers which having more than 2 factors. They are called composite numbers. But one is neither composite nor the prime. But one is neither prime nor the composite number. Here 2 comes here. 2 is the only prime number present here in this set. The only prime number which is even is nothing but 2. No other prime number is even except the 2. Okay. Next we have, in this standard, that is 9th standard, we are concentrating on the rational numbers. As we have discussed earlier, we know the rational numbers. Rational numbers. Rational numbers. As we have discussed earlier, rational numbers are the numbers which are in the form of P by Q, where Q should not be equal to 0. Have you understood? The numbers which are in the form of P by Q, where Q should not be equal to 0. So now, what are the properties of this rational number? Let us learn one by one. Properties of the rational numbers. What is this? What are the properties? Whenever we are studying any set of numbers, it may be natural numbers, whole numbers, integers, whatever, first we have to learn some basic properties. The first one is called closure property. Closure property. What it says? It says whether the rational numbers are closed under addition, subtraction, multiplication, division. For all the operations we have to check. After checking, we have to decide for which operation it has rational numbers are closed. What is the meaning of close? Let us consider any 2 rational numbers. Let us say 1 by 2 and the another one is 3 by 2. 1 by 2 and 3 by 2 I have considered. First I am going with the addition. Let us add these 2 rational numbers. 1 by 2 is a rational number, 3 by 2 is a rational number. Let us add them. Whenever we are adding them, as we know that 1 by 2 plus 3 by 2, since the denominators are same, keep the same denominator, simply add the numerators. 1 plus 3 is 4. What we get? 4 by 2. What is this? Whether 4 by 2 is a rational number. Have you understood? So the sum of any two rational number is also a rational number. So the sum of any two rational number is also a rational number. It means whenever you add any two rational numbers, then you are going to get a rational number only. You never get any other irrational number or like that. You are going to get only the rational numbers. Similarly, we will go with the multiplication. Usually, for your examination, only addition and multiplication, they are very, very important. Multiplication. I am going to consider these two the numbers, same numbers. I am going to multiply it. 1 by 2 into 3 by 2. When I multiply them, then I am going to get 3 ones are 3, 2 twos are 4. What is this? Whether it is a rational number? 3 by 4? Yes, it is a rational number. So, closure's property says that the rational numbers are closed. Means we will get the same rational number. They are closed under addition and multiplication. You please remember this. Rational numbers are closed under addition and multiplication. Whenever I multiplied any two numbers, I will get the same rational number. Not the same, it means we will get another rational number only. So, shall I say like this? Here, sum of any two rational numbers is also a rational number. There it must be, yes, product of any two rational numbers is also a rational number. Next we have the commutative property. So what is this commutative property? Let us observe. If A and B are any two rational numbers, simply I am going to write the symbol. If A and B are any two rational numbers, then A star B should be is equal to B star A. What is this star? Star is nothing but any operation. It may be addition, subtraction, multiplication, division. Now, let us apply for the two basic things. One is the addition and another one is the multiplication. We are not trying to apply subtraction and the division. First, let us apply the addition. For under addition, this star should become plus. So, it must be A plus B is equal to B plus A. It means commutative property says that even if you interchange while adding any two rational numbers, even if you interchange the places, the value will not change or the sum remains the same. Observe it. I have taken the example as 1 by 2 plus 3 by 2. Let us add them. You are going to get, yes, 4 by 2. Let us reverse these numbers or interchange the numbers. That is 3 by 2 plus 1 by 2. Then also you are going to get 4 by 2. The value or the result of the sum is not altered. Have you understood? This is the commutative property. So for this we can state that rational numbers are commutative. Rational numbers are commutative under addition and multiplication. I will give you the example for the multiplication by considering these two. Let us multiply them. 1 by 2 into 3 by 4. How much you are going to get? 3. Is it 3 by 4? No, sorry. It is 3 by 2. Let us multiply this. 4. Now interchange the numbers and then multiply. It is 3 by 2 into 1 by 2. How much you are going to get? 3 by 4 again. Observe here. Rational numbers, whenever you are multiplying, even if you interchange the digits or even if you interchange the numbers, product is not varied or the product remains the same. Here sum remains the same. That's why commutative property holds good for the rational numbers under addition and multiplication process. Have you understood? I am going to repeat it. Rational numbers are commutative under addition and multiplication. Next we have the third type of property. Our third property is considered as associative property. Associative property. In the last case, that is in the commutative property, we have taken only two rational numbers. But in case of associative property, we have to take three rational numbers. Shall I write it here? Observe it. So, if A, B and C, I am considering three rational numbers. In the previous case, I considered only two rational numbers. Here I am going to consider three rational numbers. A, B, C. Then I can write like this. A star B star C is equal to A star B star C. What is this, sir? You have written the same thing. Yes. Now observe. It says associative property. That means whenever you are doing addition and the multiplication, then even if you associate in different manner, here I have associated A and B. In this case, I am associating B and C. In other words, instead of using associative word, I can use grouping. If you are performing the addition or the multiplication, even if you group the numbers in a different way, then also your result must be same. Let us observe. I have already taken 1 by 2. The another number is 3 by 2. Another number is 5 by 2. I have taken three rational numbers here. Let us do this for operation. That means let us club A and B together and then we will go with the C. First I am going to club this. 1 by 2 plus 3 by 2. First I have to perform this. For this result, I have to add 5 by 2. Let's see what happens. What is this? To remove this bracket, first I have to do this operation. That is, yes, tell me. Simply 4 by 2 plus 5 by 2. Let us add them since the denominators are same. keep the same denominator, add the numbers. That is 9 by 2 I am going to get. Let us find the right hand side here with the same numbers by grouping in the other. Here I have grouped A and B. Here I am going to group B and C. A 1 by 2 plus. I am performing only for the addition first and then I will do for the multiplication. Now I am grouping B and C. What is B? 3 by 2 plus 5 by 2. Let's do this. 1 by 2 plus. To remove this bracket, first I have to add these two. Let's add them. 2. 3 plus 5, 7. Sorry. 3 plus 5, 8. Now let us add them. 2 is in the denominator because we are having the same denominator. Simply add the numbers. 8 plus 1 is 9. Observe here. In both the cases, I get the same 9 by 2 even if I group them in a different manner. Here I have grouped AB, here I have grouped BC. Here I have associated AB, here I have associated BC. Sir, can I associate A and C? Of course, you can do it. A star C star B. That's what the meaning of associative property. Rational numbers, if you take 3 rational numbers, even if you group in any way, while adding, you will get the same result. Result will not vary. Result will be the same. Have you understood? Shall I go with the same thing with the multiplication? Addition. Rational numbers are associative and are addition. Now we are going with multiplication. For multiplication it will be A into B into C. You can group in the other way. A into B into C. Here I have grouped A and B. Here I have grouped B and C. You can also change it. It's your own wish. What is A? 1 by 2 into. What is B? 3 by 2 into. What is C? 5 by 2. That is equal to. Let us check it out first for the LHS and then we will go with the RHS. Let us multiply them. Whenever you are multiplying, simply numerator with numerator, denominator with denominator. 4 3s are, sorry, 1 3s are 3, 2 4 2s are 4 into 5 by 2. Let us multiply them. 4 2s are 8, which is in the denominator, 15 in the numerator. 15 by 8 is the result I got for the LHS. Let us apply the same thing for the right hand side also. Here I am grouping these two now. 1 by 2 into 3 by 2 into 5 by 2. Let us multiply them. 1 by 2. First I have to remove this bracket. So remove this bracket. First I have to multiply these two. This is 15 by 2 2s are 4. Let us perform the next step. 4 2s are 8, 15 1s are 15. Did the result change? No. So, rational numbers are associative under addition and multiplication. Addition and multiplication. This is very important. You should know. You can also say that associative property holds good for the rational numbers under addition and multiplication, but not under subtraction and division. Have you understood? Next we have distributive property. You should understand this. Distribute. What we have to distribute, to whom we have to distribute. Here also we are taking 3 elements. There are 2 different types of distribution. First, multiplication over addition. Whether the number which is multiplying can be distributed over the adding numbers or not. Let's check it out. It like this: A into B plus C. That means the multiplying number should be distributed for these 2 numbers. It means this has to be distributed once for this B and this has to be distributed once for this C. Between that there is an addition. These are the 2 adding numbers. For these 2 I have to distribute A. That is multiplication over addition. Multiplication distribution over addition. Yes, I can write like this: A into B. Multiplication is distributive over addition, plus A into C. This A, which is the number which is multiplying, has to be distributed for these 2 numbers. Observe here. For these 2 we have the same numbers. So this A has to be distributed for these 2 numbers, but these 2 numbers are adding. Let us check it. We can take the same numbers. 1 by 2 should be distributed among 3 by 2 plus 5 by 2 numbers. I am going to consider the left hand side first. So here 1 by 2. Simply I know that first I have to perform the operation which is present in the small bracket. Let us do it. This is 2, 3 plus 5 is 8. Am I correct? So now let us multiply. 8 ones are 8, 2 twos are 4. I got 8 by 4. I have to get in the RHS also. What is RHS? It is A into B plus A into C. A 1 by 2 into B, it is 3 by 2 plus A, it is 1 by 2 into C, 5 by 2. Let us do this operation. 2 twos are, yes, 4, 3 ones are 3. I am adding these 2. Again I have to multiply this. 2 twos are 4, 5 ones are 5. Whenever we are adding, we know that the denominators are same. Keep the same number as the denominator. Simply add the numerators. What you get here and here? Observe. So, rational numbers are distributive over addition. Can you check it for addition distributive over multiplication? Is it possible? Try it out. Next we have additive identity. In the previous classes already we have learned what is the additive identity. What is additive identity? If a number is present in the set of natural numbers or in the set of rational numbers, a number is present in the set of rational numbers. When you add that number, additive, When you add that number to any number, you are going to get the same number. For example, 3 by 2 plus 0 is 3 by 2 only. Have you understood? 10 plus 0 is 10 only. 105 plus 0 is 105 only. 0 plus 99 is 99 only. When 0 is added to any number, you will get the same number. Therefore, 0 is the additive identity. 0 is the additive identity. Similarly, we have multiplicative identity. Multiplicative identity. Multiplicative identity. What is this multiplicative identity? In the set of rational numbers, we have the one more set number which is having some special speciality. What is that speciality? If any number is multiplied with that number, say 1, we are going to get the same number. Here, if any number is added to 0, we will get the same number. Here, if any number is multiplied with 1, we will get the same number. For example, 10 into 1 is 10 only. 105 into 1 is 105 only. 1 into 99 is 99 only. So 1 is having some special character, that is called multiplicative identity. 1 is called multiplicative identity. Additive identity is 0. Multiplicative identity is 1. Next we have next type of numbers. So next type of questions, what can be asked? That is, here they can ask you to find out a few rational numbers between any two given numbers. Finding rational numbers between given numbers. Given numbers. Finding rational numbers, any number of rational numbers, that depends on the question. Finding rational numbers between given numbers. For example, I am going to write 3 and 4. Sir, you have written whole numbers. What about now? They are rational numbers? Yes. Now I have to find 3 rational numbers between them. How can I find? If there is nothing in the denominator, means 1 will be there. Okay. I want to make this as 2. What I have to do? Or 3. Just simply by changing the denominators, we can find any number of rational numbers between the two numbers. For these two, I can find. Observe here. The same 3 1 by, I am going to multiply both numerator and denominator by 3. Let us say 3 into 3 into 3. The same thing here. Into 3 into 3. How much I get now? 3. 3 3s are 9. Sorry. 3 3s are 9. 9 by 3. Next we are having here 12 by 3. How many numbers I have to find out? I have to find out 3 numbers. Let us observe. After 9, 10 by 3 is its next number. 11 by 3 is the next number. Next number is 12 by 3. Its next number. So, these two numbers 10 by 3 and 11 by 3 are present between 9 by 3 and 12 by 3. 9 by 3 is nothing but 3. 12 by 3 is nothing but 4. So, between 3 and 4, we can find these two rational numbers 10 by 3, 11 by 3. Is it possible to find out only two factors or two numbers? No. We can find out any number of rational numbers between the given numbers. I have considered here two numbers. Now I am going to consider some other number. For example, 1 by 2 or 3 by 2 and 4 by 2. Let us say they are completely different. They don't have any common denominator. So what should I do? First I have to make the denominators equal. How can I make the denominators equal? Multiply this denominator for both numerator and denominator for this number. This numerator for these two. Observe here. 3 by 2. Denominator is 3 in the next term. So multiply 3 for both numerator and denominator. It became 9 by 6. Have you understood? This 2 has to be multiplied with these 2. 4 2s are. So 2 into 4 divided by 2 into 3. So it becomes 8 divided by 6. Now the denominators are same. Have you understood? Now the denominators are same. Still 9 by 6 is there, 8 by 6 is there. Sir, again I cannot find it out. What can I do? I can place a 0 here whenever. It means I have multiplied with 10. So numerator has to be multiplied with 10. If denominator is multiplied with 10, numerator has to be multiplied with 10. Now observe it. It is in the decreasing order. 4 by 3 is lesser than 3 by 2. Am I correct? So this is lesser, this is greater. So we have to going towards the lesser one. So which are the numbers between that? 89 by 60. 90, 89. Lesser. 88 by 60. 87 by 60. Have you understood? Similarly, it goes with 81 by 60. After that, 80 by 60 will come. Have you understood? In this case, just by equating the denominators, we can find any number of rational numbers between the given two numbers.